Alright, if you guys could please turn to the page in your notes that looks like this. 2.6, prove statements about segments and angles. Alright, a proof. A proof is a logical argument that proves a statement is true. Now, a special type of proof is called a two-column proof, and this is the type of proof that we will be using mostly in this class. A two-column proof has numbered statements and reasons, and corresponding reasons that show an argument in logical order. It looks something like this. When we are setting out to prove something, you're usually given a given and a proof. And generally, you start with your given and you end with your proof. We'll do an example of this. It looks something like this. A theorem is a statement that can be proven. Alright, example 1. Use the diagram to prove the measure of angle 1 equals the measure of angle 4. Okay, so we need to prove that this angle is congruent to this angle. We're given that the measure of angle 2 equals the measure of angle 3 and the measure of angle AXD, that's this angle, equals the measure of angle AXC, that's this angle. I'll draw two arcs for that. Okay? Alright, so the measure of angle AXC equals the measure of angle AXD. We're given that, so we're going to write given. The measure of angle AXD equals the measure of angle 2 plus the measure of angle 1. Or 1 plus 2. That's the angle addition postulate. Hopefully you guys remember that. Likewise, the measure of angle AXC equals the measure of angle 3 plus the measure of angle 4. And we know this because this angle is made up with this angle and this angle, and this angle is made up with these two angles. Now, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4 because these two angles are equal. Basically, I just substituted angle 1 plus angle 2 for AXD, and angle 3 plus angle 4 for AXC. When you substitute something for something else, it's a substitution property. Whoops, can't spell. Okay, now, we're also given that the measure of angle 2 equals the measure of angle 3. So, we can substitute angle 3 for angle 2 because these two things are equal. So now I have the measure of angle 1 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4, which means I can subtract angle 3 from both sides, and I'm just left with angle 1 equals angle 2. When you subtract something from both sides, that's a subtraction property of equality. Alright, let's go on to page 2. Theorem 2.1, congruence of segments. For any segment AB, AB is congruent to AB. This is pretty much the same thing as the reflexive property of equality, except now we're using a congruent symbol instead of an equal sign. If AB is congruent to CD, then CD is congruent to AB. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Pretty much the same thing is true for angles. For any angle A is congruent to itself. If angle A is congruent to angle B, then angle B is congruent to angle A. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Example 2. Name the property that is illustrated by the statement if angle 5 is congruent to angle 3, then angle 3 is congruent to angle 5. Obviously, this is the symmetric property of congruence. Notice that it's of congruence and not of equality because we're using a congruence symbol. Okay? Alright, I'll let you guys do the checkpoint. Let's move on to page 3. Sorry, I keep clearing my throat. Got a little tickle. Okay, if you know that ray BD bisects angle ABC, prove that the measure of angle ABC is 2 times the measure of angle 1. Alright, so we're given that BD bisects ABC. Now, remember, bisect means, bisects means that it basically just cuts it in half. So this angle is congruent to this angle. This is given. Now, because it bisects, like I said, angle 1 is congruent to angle 2. That's the definition of an angle bisector. If it bisects the angle, it cuts it exactly in half. If they're congruent, that means they're equal in measure. That's the definition of congruent angles. We know that the measure of angle 1 plus the measure of angle 2, if you put these two angles together, you get the whole angle, angle ABC. That's the segment addition postulate. But if angle 1 equals angle 2, we can substitute angle 1 for angle 2. That's the substitution property. Which means that 2 times the measure of angle 1 equals the measure of angle ABC. Okay? Distributive property. Kind of backwards distributive property. I think you could also say combine like terms. Or simplify. Any of these would work. But these notes decide to use distributive property. Alright, concept summary. Writing a 2-column proof. Given AB is congruent to CD, prove CD is congruent to AB. Okay, so we know AB is congruent to CD. That's given. If they're congruent, then they're also equal. That's the definition of congruent segments. If they're congruent, that means they're pretty much the same length. If AB equals CD, then CD equals AB. That was a property that we learned before. And once again, if they're equal, then they're congruent. Okay? Alright, let's go on to the last page. Okay, there are 2 exits between rest areas on a stretch of interstate. The Rice exit is halfway between rest area A and the Mason exit. The distance between rest area B and the Mason exit is the same as the distance between rest area A and the Rice exit. Prove that the Mason exit is halfway between the Rice exit and rest area B. Okay, basically you need to draw this out. So here's our diagram. The Rice exit is halfway between rest area A and the Mason exit. The distance between rest area B and the Mason exit is the same as the distance between this and this one. So this equals this, and this equals this. I'll draw that out. So we know that AR is congruent to RM, and we know that AR is congruent to MB. So we need to prove that M is the midpoint of RB. Let's do this. So R is the midpoint of AM. Basically, R cuts it in half. We're given this. And we're given that MB equals AR. If R is the midpoint of AM, then AR is congruent to RM. That's the definition of a midpoint. It cuts it in half. If they're congruent, then they are also equal. It's the definition of congruent segments. Now, if MB equals AR and AR equals RM, then MB equals RM. That's transitive property. Transitive property of equality. And if they're equal, then they're also congruent. And if they're congruent, then M must be the midpoint. In order for these to be congruent, M has to be smack dab in the center. Definition of a midpoint. Alright, I'll let you guys do the last checkpoint, and that's all for today. I'll see you guys tomorrow.